Hello from your favorite Grasslands PR team. Today we're back with another reason why these overlooked and underappreciated ecosystems are objectively the best biome. I'm Nicole.
I'm Rachel.
And I'm Allan. And let's heal the world, guys.
Oh my god.
Whoa.
Yeah.
Tall order.
Yes. Yeah, but that's what we're talking about today.
Okay. A tall order?
French
healing.
fries. I'm kind of
Yep.
hungry.
Giraffes.
God.
Ooh. I like
No, we're not
giraffes
talking
too.
about tall things. We're talking about things
you
that are
said
short.
we were.
Okay. Guys, we're talking about plants.
Those
Those
can
can
be
be
tall.
I'm sorry, Allan. Would you like to tell us?
The best biome is produced by our All right. No, okay. Well, I'll resist canceling the episode.
Okay.
And
Thank you.
we'll dive into my topic for this month, which
Correct.
is phytoremediation. That's a great word.
It is a great
That's
word.
a good word.
That's a really grabby title.
Ooh,
Yeah.
yeah. You know, it's fun to say. Feel free to say it all together right now.
Phytoremediation.
And
job.
yeah, all that means basically is fixing stuff with plants, specifically pollution. Okay. Phytoremediation is just using plants to extract, immobilize, contain, or degrade contaminants in soil, water, or air.
Oh, okay. Yeah.
Yeah, that's the entire concept there that we're going to dive into. It works for a lot of different kinds of pollution too. Okay, everything from petroleum hydrocarbons to solvents and heavy metals, even salt, which is not toxic to us, but can be an environmental pollutant.
Yeah, and can be toxic to plants.
Indeed. Oh, very toxic to plants. And even radioactive stuff. So,
Nice.
yeah. So we're going to get into that. It's kind of cool. It's a strategy that I've seen this utilized before. I don't know if you guys have actually been to a site where it's like, oh, this is actively happening.
Yes.
I've seen it used in an aquatic system. Okay,
That's mainly what I'm remembering too. Is
Yeah.
aquatic systems.
yeah. It's also it can be integrated frequently with like municipal water systems, like infrastructure. The place that I have seen this at work on the largest scale is a place in the Dallas-Fort Worth area. It's called the John Bunker Sands Wetlands. Have you guys heard of that?
No.
Okay. They're the largest human-made wetlands in the United States.
Human-made. Okay.
Yes. Basically, it used to be a cattle ranch, okay, right by the East Fork of the Trinity River. And the landowner there started converting some of the cropland back into wetlands. That he was a conservationist. He practiced all these rotational grazing, regenerative kind of practices, and wanted to convert a significant amount of his farmland, his family's farmland, back to wetland. In doing that, they actually started this sort of public-private partnership where they would be siphoning water off from the Trinity River, which is where that whole metro area gets their water, right?
Okay.
And they would run it through those wetlands. So they have massive wetland cells. They would put the water through them. The plants would take all sorts of bad stuff out of the water. And then they would shoot that back through a pipeline all the way back up north. And it would re-enter the water supply. And it would get treated like for consumption.
Sure.
There's like 90 million gallons of water a day that go through those wetlands. So it's a huge amount of water for a huge amount of people. And it's also just like a really gorgeous spot. Like it's nice, it's ecologically lovely. So that's like just a cool little, conservation situation where they put this phytoremediation idea into practice. But this got me wondering, like, this technology exists, but it shouldn't it be more widely used, right? Like, like it makes a lot of sense. It's very intuitive. Why aren't we seeing it more frequently in contaminated spaces? And, like, why isn't it used in terrestrial environments and grasslands and things like that? There's a lot of, degraded and contaminated prairies out there that we've talked about. And lots of situations where, grasslands have a direct impact on things like groundwater, surface water, right? We've talked about that on the podcast many times, whether it's, the Paramo or Aso or the Brahmaputra. Like, these are environments where grassland can really help to improve just the general health of the landscape.
Yeah.
And so why aren't they doing this more often? I found a number of papers that were asking that exact same question. I actually found papers that were all published like within a pretty pretty close proximity to each other from all over the world, like asking the same question. Like there's one in Korea that was like, why don't we do this more? Yeah. There's one in India where like, we should be doing this more. There was one that was an American study, a very widely cited opinion paper that framed this issue really well. This one was published not quite 10 years ago. So this is back in 2016, which I think just gives a good overview of the issue and talks about the opportunities and the challenges of using phytoremediation. Okay, just as a general practice. So we're gonna look and see what this paper tells us, and we'll see where we're at now. Okay, almost 10 years later with this practice.
Ooh, okay.
Okay.
Which paper are we diving into?
So we're going to dive into, this is an American paper called Taking Phytoremediation from Proven Technology to Accepted Practice.
Ooh. That's a good title.
This was published, by Karen Gerhardt. Yes, Perry Gerwing and Bruce Greenberg in Plant Science back in 2016. So, 3 main things they talk about in this paper. Number 1, phytoremediation can be very effective, and we'll talk about how it works. Number 2, phytoremediation is underused despite its proven success potential. Okay. And number 3, what are the barriers to making phytoremediation more common? Because the investment in the technology massively lags the amount of successful academic research. So, what's going on there? We'll talk about it.
Is it money?
Nicole? That's very, very shrewd of you to think that this might all be a money issue.
Yeah.
Definitely plays a part of it. Okay. But we'll get to that in a bit.
It is less expensive also just to not fix anything.
Yeah.
Yes and yes
it's short-sightedly. Yeah.
Yeah. And
Anyway.
yes. Guys, we're healing the world.
Yes.
Right.
I feel like you were both wanting to steer this bus a little closer to the abyss right there.
I just said money.
I'm telling you, we're healing the world today.
Okay.
Oh, okay.
Ready.
Thanks, guys. So
Ready.
bear with me.
I'm bared. Born? I'm bored.
You're bored?
No.
That's rude.
Let's just call this off. Okay, guys. So how do plants heal a contaminated environment? Let's talk about what is going on with phytoremediation. So it's really actually very, very simple. When we're talking about in a terrestrial environment, it's all just a natural consequence of how plants do their thing. Mm-hmm. Okay. It's really convenient. This is why this makes so much sense. Basically, it is just a natural consequence of how plants are altering their soil environment. Mm-hmm. So starting with the processes at play here, let's think about what a plant does to its environment. without turning this into like an organic chemistry lecture.
Yeah, that'd be great.
So, first of all, a plant creates structural changes. Okay. Roots shoot into the soil. They break things up that are compacted, and they allow for water and oxygen to start moving through the soil environment. Much better than just bare ground. Okay. Number 2, they create a root zone or rhizosphere, which, as you remember from our dirt episode, is a pretty active place. Okay. You look at a grassland, most of your biological activity is happening below the dirt. Okay. Those rhizospheres are going to have unique microbial communities with special bacterial species or endemic bacterial species called rhizobia. And those are going to greatly alter the chemical environment of the soil. And what do bacteria like to do?
Eat
And
poop.
Exactly.
That was the answer.
Yeah.
Great.
Rhizobia are going to exude all sorts of organic acids.
Ooh.
Okay. Those are going to end up bonding and reacting with things in the soil, including contaminants, and are going to possibly fix them, impede their movement, or degrade them altogether. Since these are organic acids, it's important to remember a lot of these contaminants are themselves organic compounds, such as petroleum hydrocarbons. Right? An organic substance is just anything that has carbon. We have carbon. Oil has carbon.
We're pretty organic.
Yeah. So, and when we're talking about like these petroleum like hydrocarbons that are in soils, we're not talking about just gasoline and diesel. We're also talking about like.
Sorry. Go ahead.
We're not talking. What happened?
What? I don't know. It's just we're not just talking about gasoline and diesel. It's just I don't know. It tickled me. I don't know why. I can't explain it.
I can't either.
Okay. I'm glad that's so silly to you. Because you're right, Nicole. We're also talking about aromatic hydrocarbons. Okay. Volatile organic compounds. What does it mean to be volatile in chemistry? Do you guys remember?
It means you have you're a charged particle and you want to rip through space and matter and bond to things and destroy everything in your path not electronically, atomically.
Yes. Okay. That sounded really scary. And it kind of is. We're talking about like a volatile compound. It's just like how readily is it going to just fly into the air?
Doesn't that mean it just like has an odor?
Volatilizing like compounds cause like odors for us. Yeah. Like we detect a lot of volatile compounds in the air as scent.
They are in the air.
Yes, because they are in the air. Because smell is
volatile.
Because smell is particulate. So if you're smelling something, it's actually in your nose.
Oh God.
It's in your body.
That's. I was just immediately thinking about farts.
Yep.
Yep. It's pretty disturbing. Anyway. Yeah.
Yeah. No. Life is a terrifying mystery. But yeah, no, volatile organic compounds. So these are things that, since they, like Rachel said, just want to jump into the air and tear through space and cause havoc, these can actually be a significant human health problem. Okay, these are compounds like benzene, which are, in your liners and plastics and stuff like that. Toluene, which is an industrial solvent known to cause birth defects and reproductive harm, and xylene, which is used in everything from making rubber to leather to paint to pesticide, and has potential effects on your central nervous system. These are not things you want in your environment. Okay?
Yeah.
But good news.
Plants.
Bacteria, rhizobia, and plants are going to help degrade those substances by exuding just the things that they normally do. Okay, so plants and bacteria can help break down those molecules of contaminants, and in some cases can even just pull them into the plants themselves. So they're not in the soils. They're not in the environment as much. when these compounds, when these molecules are small enough, the plant will actually pull them in, and they get degraded inside the plant by the enzyme activity happening in the plant tissues. Okay, enzymes are just breaking this stuff down. They may accumulate, they might stabilize within the plant, or sometimes they might get pulled all the way to the plant leaves after they're broken down, and then they themselves are going to just volatilize, evaporate, okay, off of the plant leaves. They get dispersed in the atmosphere. They don't redeposit in the environment.
Okay.
Yeah. So it's kind of cool. Like there's various ways this might be happening. That's what happens with the organic compounds that get broken down. What about the inorganic compounds that we get that pollute our environments? Okay, things like salt, right? NaCl, no carbon there, or heavy metals are a big one. Plants are also really good at dealing with these. That's been proven in a number of studies. So, for example, let's talk about heavy metals. These can be very dangerous at even low concentrations to human beings and to other animals. We're talking about non-essential ones like arsenic, cadmium, lead, chromium. These are all out there. They can get into soils through various means. And we don't really want them there. It's not good. Okay.
I'm immediately thinking, though, like there are plants that have and utilize arsenic and things like that. And so I'm immediately like clicking like, oh, yeah, of course, if it's in the environment and it can literally just use it, it would. Yeah,
absolutely. Well, and plants, right? Plants already, they have to have, because there are 8 metals that are like essential nutrients for plants.
Oh.
Okay. So they have to have a way of pulling those metals out of the soil anyway. Right. Things like copper, zinc, iron, right? These are like, nutritional metals, right? Manganese. I don't remember what the other 4 are. Molybdenum.
But I don't know.
Yeah, you lost me.
First
ones, yeah.
But there's a bunch of like, they need these trace element metals as part of like their own health to like, to be a stable plant. So they do have a mechanism for pulling these things out of the soil. They either like will absorb the ones they need, and the others can end up getting immobilized in the roots if they're not being extracted into plant tissues. They might they kind of put out these compounds that are going to help dissolve these metals in the soil from their their unavailable states,
Okay,
right?
yeah.
And then start pulling them into the plants if they can. Or if they're not the kind that they need, they might end up just sticking metal ions like to their cell walls and things like that. Right?
Yeah. I have a question, but you might be answering it.
No, go ahead.
Does this hurt the plants, or do we not care about plants because we have no evidence that they experience pain and sentience?
Does it hurt the plants?
Yeah. To like have because it sounds like they're targeting the useful nutritional metals.
Yes.
And then maybe incidentally pulling other stuff out.
Yeah, right. And well, that's the thing. Like for the metals that they don't need, for the metals that can be harmful, plants have it's a hugely diverse group of organisms, right? So some of them are more sensitive than others to the presence of a contaminant. But in a lot of cases, these plants they have ways of just socking away things they don't need. Whether that's just, like I said, they, instead of like passing them through a membrane and putting them through a cell wall, they just might stick them. Like they'll just kind of either get bound up in the root zone, or they just get stuck to root tissues, like fixed basically.
Interesting. Okay.
Yeah. So there's a lot of ways where they deal with that issue.
That's cool.
Yeah. And you talk about the sensitivity of plants. There was one cool study where there was they studied grasslands in former mining sites in the Iberian Peninsula. And they were looking to see like what's the ecotoxicity situation here, because there's a lot of metals like that have been brought out of the earth and are on the ground now, right, in the dust and things. And they tested like 171, I think, species of plant among these former mining sites, and they found like all these plants have a crazy high concentration of heavy metals in them, and they're fine.
Interesting.
Yeah, the problem was like animals could be eating these. That's
Right, yeah.
The plants are fine. Okay.
Yeah,
But yeah, it could be bad for like forage and stuff. So that was the issue there. So they really can. They do have a good way of handling of heavy metal toxicity. The way they do that, the compounds that they're using to bind to those metals are called chelators, and that's CHELATOR, chelator, and it's actually the exact place where we get the medical treatment that you'd use for heavy metal toxicity in a person.
Oh.
These are the same compounds. If you had heavy metal exposure and you went to a hospital, they give you chelation therapy, which are sometimes synthetically made, but are often derived from plants and microbes. And they'll just go through your body. They'll bind to all the metal ions you've been chugging, and then you'll just pee them right out. Yeah, it's very cool.
Wow. Okay.
Yeah.
That's really cool.
Yeah. So they're good at sequestering those freely moving things and just socking them away. Okay.
Aren't you then peeing them right back out into the environment? Never mind.
Yeah, but they're bound to another ion.
Oh, so they're not like available. Yeah.
Yeah. Yeah.
So that's still better.
Want to lock it down. Yeah.
Okay.
It's also, I mean, you got to get it out of your body, right?
Well, yeah, for sure. I was just
You are not a plant. You can't hold on to all these heavy metals.
watch me.
Rachel.
I want to become silver, colloidal silher. Like that mummy lady.
No.
Oh.
The cult leader.
Yeah.
Oh, God.
Remember her?
No.
Yeah, I do. That's the Mother God.
Mother God.
Yeah. Ooh, what a fun
I shouldn't
one.
laugh. That was horrifying.
It was
It's bad.
deeply upsetting.
Yeah.
Okay. The uptake by plants themselves prevent those contaminants, from leaching further into the soil, potentially into groundwater. So sometimes you have plants just physically extracting contaminants from soils up into their own bodies, and that way they don't get pushed by wind and rain further from the site that they're in, because we don't want that, right? If things start leaching below the root zone and towards, where we have our groundwater, that's a very serious problem. But plants can help slow that down or stop it altogether. Some plants they call hyperaccumulators because they're able to just pull in really, really high concentrations of inorganic stuff. Other plants that have like really high biomass, especially high root biomass, like
Prairie plants.
prairie plants, grasses. Yeah, absolutely. Did you just say plants?
I was thinking in my head grass, and then the word that came out of my mouth was plants. I'm so sorry.
No, that's totally fine. You're correct, just not terribly specific. Grasses are really good and even possibly more efficient at phyto extraction, as they call it, just because they put so much biomass into the rhizosphere.
Sure.
Right? Just huge amounts of it.
Are there particular orders or families that, like, a lot of those hyper accumulators, is that what you said, belong to, or is it kind of spread out?
Yeah, it does kind of spread out, and it seems to be like a fairly specific property of the plant. Some that like I saw were considered like vetiver grasses were used in a lot of, or vetivers were used in a lot of like experiments.
What's a vetiver?
Vetiver, it has another name. Shoot, it has another like common name that I think I'd have to look this up because I forgot off the top of my head. It has a common name. I think that's more probably recognized by.
No, I think it's just known as vetiver.
Okay.
Yeah, they said also known as, and then gave it scientific name, which is vetiver something nonsense. So
okay, yeah, but that's like an example of one. I saw a lot of use of like poplar trees. Like specifically poplar trees are a common phytoremediation one. Industrial like hemp it was used in a lot of places. So, but those are just some examples. But it really varies quite a bit. I think it's sort of a specific property of the plant.
Okay.
Where was I? Oh yeah. So some plants are just really, really good at pulling stuff into their bodies. At really heavily contaminated sites, those plants, like in that study where with the mining sites in Spain, they do need to like actually do something about the plants that they get. So when they're using this to like manage a contaminated site, they do need to go in and harvest that grass, because it's going to be like, okay, cool, we got the inorganic compounds out of the soil. They're in the plants now. We got to get it out of here. So they'll go in, harvest those sites, and then do something else with it, whether that's disposing of it, incinerating it, sometimes recycling it, burning it, and putting it through some like decomposition processes to actually just get the usable metal back out of it.
Interesting.
Which is kind of cool.
That is cool.
That's wild.
Right? It is. It's interesting. Because if you don't do that, otherwise it's just going all back into the environment when the plants die or when animals eat it, and then it gets, goes up the food chain. Not great. Okay. So regardless of how plants are doing this, we talked about a couple different ways. They're either stabilizing things from moving. Okay. They're either absorbing things and degrading them and then volatilizing them. Okay. Or they're just extracting them out of the soil and holding onto them in their own tissues. All of that activity is going to have a really positive effect that goes well beyond the roots of the plants. Okay, and it helps the soil return to a more productive state. It's very cool. They also do some other things to like enhance how well this works. So it's not uncommon in a phytoremediation model to like introduce other things that are going to help the plants do their natural stuff at just a higher level. Sometimes they'll intentionally couple plants with certain microorganisms, okay? Or they will inoculate them with certain kinds of fungus. Okay. Like either fungus on the outside of roots or the kind of fungus like that mycorrhiza that goes inside root tissues that help them just process those contaminants better.
Sure.
Yeah. So it's in a lot of ways, this is and they also do things like amend soil. Okay, to help this out, because there's generally in a contaminated site not going to be a lot of oxygen and organic matter and stuff like that because it's super polluted. So they'll add things to it, composts and biochar and fertilizer and stuff that helps get those plants functioning better.
Sure.
This is really, in a lot of ways, just like planting any other native garden, right? Because what you're trying to do is just get plants to be doing their natural, normal, resilient thing, just in a really, really bad starting point.
Yeah.
Right? And like a worse starting point than most native gardens are going to be.
Yeah. That's actually a really interesting point, though, because I remember when I was starting to do some gardening in my yard, people were discussing like whether you would have lead contaminants in your yard because of lead paints that were used on your property, and measuring, like that being an important thing to measure before you start eating tomatoes. Yeah. So like phytoremediation on a localized level, is there a way to like plant specific things that would take lead out of your soils before you start planting your tomatoes?
Yeah, so that's actually something that's been studied as well as like co-planting. Basically, if you take some hyper accumulating plants, right, and you co-plant them with the other things that you want to eat, then that does have a positive effect, because the hyper accumulators are going to be like, they're pulling that stuff in.
Yeah.
So the other the botanicals, the vegetable plants aren't. So that's, that is, when you're talking about looking for a way to make a land reusable from an agricultural standpoint, like doing this co-planting can actually be kind of a good way to like speed that up, because you're having you're having the plants that are sort of taking the hit of the environmental contamination, and then the other plants that are going to be able to thrive among them.
That's really cool that you can do it simultaneously. I would have thought you'd have to, I don't know, prep the soil first. Yeah. But if it's not that bad, I guess.
Well, and sometimes they'll like rotate things out. So they will plant like put a cover crop of hyperaccumulating things down first, harvest that, get rid of it, then start planting some other stuff. And, so it can be a little bit of a process. But yeah, they've demonstrated that these, in the lab, in the field, even on large scale restoration projects, that these ideas work in practice.
Cool.
Yeah, it is cool. Exactly, Rachel.
Why are we doing this all the time?
That's a great question. Well, we're going to get to that in a minute. Let's see. Oh, they've also done a little bit of work with doing like selectively breeding plants specifically for phytoremedial properties. So there's been a little bit of work with, certain bacterias that are going to degrade VOCs really fast. There was one study where there was a certain kind of endophytic bacteria, so something that they put right in the root tissue that would pull in trichloroethylene, not a good one, a bad VOC, and it would reduce the amount that compound was leaving the plant by 90%. So it was doing a great job of pulling it in, this specific bacteria, breaking it down, and then not letting it back out into the environment. They had also done some studies with mutant strains of tobacco and sunflower that they found were really good at pulling out zinc from soil and things like that. So, it's possible to breed some plants that are going to do this that are going to have this function specifically, that could be spread out in whatever you're already having out there. Yeah, kind of cool. So, are we sure that it works? Yes, there is a very strong body of evidence supporting these ideas. Like I said, in the lab, in the field, in large-scale projects. Also, it's cheaper. Shouldn't be that surprising that it's cheaper to just plant plants, because the other option, or the most common way that heavily contaminated soils get dealt with, is excavation, disposal, landfilling, sealing, and barriers.
That doesn't seem like it actually helps anything.
Well, yes and no.
See it doesn't exist.
Oh my God.
So, but it's a big operation that yes, can really, causes huge irreparable harm to a landscape. Yes.
Yeah.
It's real bad. So by comparison, planting plants is a lot cheaper. So why do they opt for that excavation option? Generally, excavation is, as this paper says, quick and dirty.
I was gonna say,
More expensive, but verifiably quick and dirty. But it has the unfortunate side effect of treating soil as disposable, as just disposable waste. When in actuality, soil is not a super renewable resource.
Yeah.
Okay. If you remember from our soil episode on this show, we talked about how those processes are really, really slow. There's geological functions happening. There's ecological things happening. It takes a long time for soil to form. So excavating and then removing it completely doesn't really do the environment any favors. So phytoremediation would be better in situations where it's an option. But there's unfortunately also a time cost to this, right? Going in with bulldozers, removing soil, contaminated soil by the ton doesn't take very long. But, reestablishing a functional plant community does take time. So, that's kind of the main issue there, is the time cost. And sometimes there's also just there's not that guarantee that it's going to solve the problem completely. I think that also tends to be an issue. That tends to be a big barrier, is we want to for example, in 2022, here in our home state, Kansas, we had a massive pipeline burst. Up in northwestern Kansas, Keystone XL pipeline dropped something like 500,000 to 800,000 gallons of crude oil on the Panbaker farm. Okay, so
the biggest oil spill since like the BP like ocean spill. Like it is bad.
Yeah, it's really, really bad.
Yeah.
Okay, so when you have I think is it TC Energy, I think are the people who own the Keystone pipeline. Like they have a responsibility to go in and clean that up. Okay. They want to make sure that it gets done, and they want to make sure that they're doing it in like the fastest way possible so they can resume their operation. Right.
Yeah.
And that cleanup's been going on for years. It's still going on. But like, that's a situation where they like, okay, are they entertaining these other ideas? Probably not, because they just want to make sure it gets done. Like that's the objective.
But we know that it's effective.
We know that it's effective, but they want it done fast.
Yeah.
That's the really crucial thing. And they want to be sure. So they kind of go for that nuclear option of excavation.
I mean,
how is it faster to excavate that much soil as opposed to planting that many plants and then letting it go on for years? Like it's already going on for years.
Yeah. I mean, there's, I think there's phases to a cleanup like that.
Yeah.
And I think when you have that much oil, like there is unfortunately going to be some need for like, you just have to get some of it out.
For sure. Yeah.
Like it's, and there are some of these sites where there really is not another option. I think that's the main thing is it just really comes down to the time and it comes down to the complexity, because, ecology, botany, these are things that are full of variables and are generally a lot more confusing to people, compared with just simple engineering solutions, right? When you're creating a biological system, there's a lot of things that could happen with it. There could even be some potentially like undesirable consequences if the conditions change or if they're not quite right. So that's why I think there's the lack of understanding, or the lack of comfort rather, with these concepts make the other options more appealing.
Yeah. And really there is no guarantee when you're dealing with plants. I would be mad if I was a landowner and they're like threw down some seeds and went, bye. In 20 years, it'll probably be fixed. Like it's
yes.
Because it takes long-term monitoring and like all sorts of stuff. To make sure it's actually clean.
No, for sure. And like that. So that was one of like the two biggest things. Probably the biggest thing that was a barrier to phytoremediation happening is because people plant plants and then they forget about it. They would call it the plant and pray strategy. And that's not how anything works. Like, you talk about like, okay, the number one reason that native gardens fail is because people plant something and they don't do any follow up, right? So that is a huge barrier, because these things, they would, you put plants down, they fail, and then now that's an indictment of the whole idea when it's really a management issue. Okay. These things, you need stewardship, you need attention, you need to adapt, you need to change things that, to make sure it's all healthy and thriving and functioning. Okay. So it's so sometimes phytoremediation is not like, it's not the right, it's not handled properly, I think, is the main issue that they identified. Not that it doesn't work, because it's proven to work. It's in practice, are we handling things the right way? Do we have the actual like will to stick with these kinds of projects? Because when they do, like John Bunker Sands Wetlands been going on for decades now, hugely successful. Okay. So it's just a matter of commitment. And just to sort of, because I think it's another thing they noted was it's important to like set expectations with phytoremediation because it's not right for every single site. Sure. It's not a panacea. Okay. Sometimes contamination is going to be below the root zone already. And that's not really an option at that point.
Yeah.
Although the EPA did, they had been doing some, like in a fairly recent EPA article I saw at one site, they had been like pumping groundwater from below the root zone out and then like sort of putting it back on top of these plants that are phytoremediators and then letting it sort of leach back down again. So, there are some other innovations happening there. I want to go on a tangent if I can.
Yeah.
Before we
go for it.
Before we talk about where we're at nowadays. Okay. Because I was looking at like a lot of environmentally contaminated sites, just to see like, I was looking through all these EPA reports of like, well, what are some different remedial options that they take? And when we're talking about situations where there's no other option, that got me started down like some of the worst Superfund sites that we have in the country.
Nice. Yeah.
Pretty impressive stuff going on. So like, okay. Like for example, the Rocky Mountain Arsenal. Have you guys been there before? Denver area. Okay. This is a Superfund site formerly, because it used to be, they called it the Rocky Mountain Arsenal because it was literally an arms manufacturing plant. Yeah. Okay. They manufactured chemical weapons, explosives, all sorts of stuff there. They actually like had, there's like unexplosive ordnance that's out there in what is now today a prairie. There's certain parts of it that like people can't go to because they're like, it's not fully cleaned up. They're still working on it. There's also like certain landfill areas that people can't go close to because there's so many toxins in there. That's an example where they like had to put down huge barriers like on the ground, like specially constructed landfills to hold this stuff and then cover it and then cap all that with topsoil and plants and things. So it's like a functional prairie. It's cool out there now, but like, yes, they had to do a lot of work because there's no other option to confine all that stuff.
Sure.
The one that was like the very worst though, because I was curious, is the Murray Smelter in Utah. This was a site that operated 24/7 for 50 straight years, vaporizing lead.
God.
What? Superheating lead ore for lead production.
Dang.
Yeah. It's
God.
They opened in 1902. By 1907, there were farmers saying like, boy howdy, sure is a lot of lead in the air here. This doesn't feel too good.
God.
Okay. Continued operating until 1949.
All right.
And then they only shut down for economic reasons. Okay.
God.
And the old smelter stood there for another 45 years until 1994 when it became a Superfund site. Okay. So this huge lead smelting place, which is actually right across the street from this town's high school, had been there for about 100 years.
Good God.
Yeah. This was like the worst. This has the record for like being the worst Superfund site in our country's history. It had a hazard score of an 86.6, which compared with other Superfund sites tend to average in the 40s. So this is like twice as bad.
Yeah. God. Never mind. I don't want to know.
I hate it here.
But people got together. They identified this as a problem, and then they got to work and fixed it. Okay,
100 years later.
100? Yeah. Well, don't always get.
How many
things
high
right.
schoolers graduated?
I was going to
Wow.
ask if the people
Like-
of this town have been like tested for lead over the generations and what that looks like.
I mean, great question. I don't know, but it's probably
there's got to
not
be
great.
at least one study.
Probably. I didn't look into seeing like what specifically, like how this community's been affected by it. But they did do a successful cleanup. So they went in there, they removed, because they had to, thousands of tons of soil, demolished the plant, and have set up like monitoring all over the place for it now. There's currently a hospital there on that site. So it's been completely reversed in terms of, the effect that it had. So it is like, even in the really, really bad environmental cleanup situations, when there's the will to make to fix it, people can get together and make it happen. Okay, so that's I feel like that's, and the Superfund program is not perfect, obviously. There's a lot of environmental justice issues in terms of which sites get the most attention and which things are prioritized. And the EPA itself is obviously has all sorts of, as an organization with political, politically appointed people, is going to have all sorts of problems going on. Yeah. So it's not perfect, but they can make a difference, is the point.
What do they do with all that soil, though? Like, scraping it out of that place helps that place, but like they put it somewhere. Yeah,
and usually it has to go into like a special containment, or they will try to like it gets like quarantined or disposed of in another way, so that it doesn't become a human health risk, basically, because that's all they can do, With that fun little detour down EPA Superfund lane, let's look at the authors, what they recommended. Okay, back in 2016, they said we need more studies, we need more education, we need simpler language to talk about all of this, because if you're trying to explain to somebody, well, we could do phytostabilization, phytovolatilization, phytoextraction, et cetera, you're gonna lose people.
They've checked out, They checked out with the phyto part.
Yep. Phyto, what does that mean? Yes, so simpler language, better incentives, okay, because, people will, if it becomes a viable option economically, then people will do it.
Yeah.
By the way, did you know the CRP, like the cap on CRP grassland payments, it's been the same since the Reagan administration?
Yeah.
And it's really low.
That's crazy.
It's insane.
I legitimately don't know why anyone's in that program.
Yeah. No, people
they do it out of the goodness of their own heart. It's not.
Yeah.
That's it. Yeah.
No, people
Which defeats the purpose of the CRP program.
Yes.
Yeah. People were talking about how like the next farm bill needs to like triple that amount at least. So hopefully we'll see. Point is, you need incentives, right?
Yes.
Woo. Okay. And putting out just a more of a demonstrated track record of success. That's what these people identified as needing to happen. So what has happened? Well, there's been a lot of studies in the intervening years that have added quite a bit to our understanding of phytoremediation potential. There was a large literature review done just a couple years ago, 2021, that looked at phytoremediation projects with grasses and found multiple studies which showed that grasses were capable of rehabilitating sites that are moderately polluted. Okay, not the severe ones, but the moderately polluted ones, could efficiently restore those sites, even with just grasses alone. Okay, if you were planting a diverse plant community there to accelerate the remediation, then it was even more successful. They said there's still a lot of work to be done on understanding which grasses and which plants can be best applied in which situations, because this is a complicated topic biologically, ecologically, and so forth. And trying to figure out which microorganisms and which amendments we can also apply to help these things the best. But there have been, as the years have gone on, this has gained more traction as like a actual usable thing. And there are EPA sites that are using phytoremediation specifically, whether that's plants, trees, or grasses. trees, forbs, grasses, with to like a successful end in their sites. Like that is ongoing. And they are like, even with our, the Pan-Baker Farm leak, the Keystone Pipeline leak up there, they are planning to, as part of it, begin reseeding to ensure that there's, anything that gets left behind gets further degraded by the plant. So there is like, that is a part of the plan. Okay. So, so there is like, the empirical support for it continues to grow. It's really just a matter of like, we need to, keep educating people about it. And, because this is like, there's interest in doing this all over the world. And it is worth investing in, because there's just a lot of benefits that come from using this. A large, or a significant percentage of soils are contaminated with all sorts of pollutants, and so using this strategy to fix that is going to yield not only benefits for that land, but it's also going to help with things like carbon sequestration, conserving biodiversity. It's just aesthetically nice. There's lots of things that can happen from that. Could also be an economic engine, if the things you're planting can be turned into biofuels or whatever. So yeah, there's a lot of advances that have been made, but there's a lot of benefits to be realized from the practice still. Just trying to get the right mix together of the management variables, I think, is the main issue, just to get people on board with it.
Sure.
So, well, I think it's very cool. I think it's an interesting topic. And yeah, this is just another aspect of using native plants, that is going to, just another positive of using native plants, because we already know they do all sorts of other good stuff. I mean, even in healthy soils, they're good for good for the water, good for carbon sequestration, all that. So it's just a matter of, can we use them also in contaminated soils and make a difference there?
Yeah,
I think be cool.
It's cool to hear about it in terrestrial systems too, because most of my experience has been with water quality and wetlands. And so that's a cool thing. Yeah,
I think maybe, well, it's like, a lot of people don't maybe connect necessarily those terrestrial ecosystems with the impact that they have on water.
Yeah. Because they do.
They do. Yeah. Your agricultural systems, So yeah, that's my takeaway. Let's go keep planting plants and keep trying this. Just doing it the right way is the only issue, right? You just have to get people to commit. So
for sure.
Let's do it and commit to it.
What is like a timeline approximately? I'm sure it's so variable, but for a moderately, affected site.
Because it can take the plant community a few years to establish, but once it does, you're talking 3 or 4 years to like get a thriving plant community going for in most cases with these, and it is like long term. You think about the kind of I guess to answer your question, like, it is highly variable, so I don't have a good answer for you on that. But it can make a difference quickly,
sure,
and then also be useful, like keep providing benefits in the long term.
Definitely.
Yeah. Plants, guys. They're pretty cool at what they do.
I need glasses. I had to text my eye doctor the other day, and they're like, "You're overdue." And I was like, "No, I'm not. You're lying." And then I keep squinting at things. And I'm like, okay. Thank you, Allan. And thank you for listening. The Best Biome is produced through our nonprofit Grassland Groupies, dedicated to inspiring the conservation of grasslands. In the show notes, you can find our website, phone number, and social media accounts. Send us suggestions, fan mail, or hate mail. If you enjoyed the show, tell a friend and leave us a review. We couldn't do this without your support, and we'll see you again in 1 month.
Bye.
Farewell.
Guys, I'm sorry that I have really apparently niche interests when it comes to environmental stuff.